In this video, I'm going to break down our percent questions that we're going to see in Math 92. First off, just a quick baby review. So we'll just throw off a review really quick. If we see something that says X percent, this means the same thing as X divided by 100 or X times 0.01. So I like to think of this more often in the idea that 100% is one whole thing, right? Because I saw a lot of problems on the worksheet we had in class from students converting from percents to decimals and back and forth. I had a lot of things that said 0.6 was equal to 0.006%, going the wrong direction when we move those decimal places, right? So always the percents are bigger than the decimal versions of them. So this here is a big mistake. When we had that 0.6, the decimal should have moved to make this number bigger and make this 60% as opposed to 0.006. So you can either sort of think about the definition of a percent is per 100, or you can just kind of keep this in mind. And if we're going to a percent, it needs to get bigger, so we'll move to the right. And if we're going to a fraction, it has to get smaller, so we'll move to a decimal has to get smaller, so we'll move to the left. Perfect. Okay, so let's think about the basic percent questions that we hear. First off, we have this notation that comes up a lot, or how we say percent questions. So I'm just going to give us an example, and then we'll use that to sort of define what we need. So a lot of times you'll see something like 7.5% of 40 is what number? And now with a question like this, the percent question comes down to simple translation. Our big translation here is that of is equal to multiplication and is equal to, well, an equal sign, right? So if we use that bit of translation, of is multiplication, is an equal sign, and then we can just bring down the rest. 7.5%. When we bring this down, we should convert it to a decimal, so that way it's easy to work with in our calculators. Or we could use the percent button in our calculators. That's okay too. But I would probably, as I'm bringing this down, realize, oh, it's got to get smaller to become a decimal. So this is 0.075. Bring down that 40. And then what number? Well, we can bring that down as an X, right? Our unknown. So as long as we had that translation, it becomes really easy to these two pieces for your translation, it becomes very easy to figure out what it is we need for any question. And in this particular question, we're just going to have to multiply 0.075 and 40, which it appears the answer to, I had to bust out a calculator, was 3. And the variable here can be in any part of this equation. So let me just quickly write down 2 other examples for you guys to try out. So one more example here. What percent of 30 is 12? And 16 2/3. Oh, let me give us some space here. The second one we'll try. 16 2/3% of what is 15? Okay, so what I'd like you to do at this point, if you have a moment, pause the video, try this out on your own, see if you can get it right, and then come back. So if you're coming back, we have our nice things to bring down for our translation, right? We have our ofs and our is, which we can make multiplication and equals. We can start bringing down the numbers we have. Notice we'll always have 2 givens and 1 unknown, which we can also bring down as an X. The only one that's going to give us any trouble on this is this gross 16 2/3%. What I would do is I would type 16 2/3 into my calculator and then have it convert that to a decimal and then put it back into a percent. There are other ways to get there. Nothing is going to be very nice in terms of getting there. We can talk a lot about this in class, but you're going to get 0.1667. And technically that 6 is repeating forever and ever. You do want to be careful when you round something like this that you're not getting yourself in trouble by not keeping enough decimal places, because this is probably something that works out pretty, and if we round too far, we're going to get out some gross decimal answer. We might even see that here. So ideally, you probably want to keep as many decimals as you can, or just keep it in whatever the answer form in your calculator is. Now, for both of these examples, the thing that we are trying to find, our x, is not alone. So we have one more step. So in the first question, this was 30x is equal to 12. Just going to go ahead and do the 30 times x when we write it that way. And if you want to get x alone, we divide both sides by 30. And we would find that x is equal to 0.4. Now the question did ask for what percent, so we need to be careful. We'll take one more step and make this 40% after we move the decimal place 2 to the right to make this into a larger number, right? Or multiply by 100% or 1. So that's the first one. Second one, 0.1667x is equal to 15. Now I need to take and divide both sides, right, by this 0.1667. And like I said, this might get us in some trouble. Let's just see what happens when I keep this rounding in my calculator. 15 divided by 0.16667. It gives me out 98.89. Or, sorry, 89.98. Whew, dyslexic on both parts there. Now here, if we could have kept the perfect version of this, which maybe we should have, especially because that's not too hard to do in the calculator, this definitely would have been 90. Right, that's going to be the issue here. So that actually should have been our right answer. I would never give you something this gross on a test. So those of you freaking out right now, I'd never give you something where you're going to have that repeating decimal and have rounding issues. I would give you something where you could easily go ahead and turn it into a decimal. In fact, I probably wouldn't do a mixed number percent anyways, because I can't think of very often that comes up in real life. So, but that's an example of our percent questions. I'm going to give us one more example just to show you how this might work in a simple percent question, how this might work in an application question. Let's think. Sorry, I'm being slow. I don't know. Okay, so here's an example. Just to show you how even these simple percent questions, they really do look the same whether we're doing a word problem, an application, or just here's the little sentence that we saw before. So as we read through this, a used car has a value of $11,250. There's one of our numbers, which is 45% of the car's original value. So we have our two numbers. We have our is and our of. So we can already start writing out what we have here. 11,250 is our equal sign. 45% we can bring down as 0.45. And then our of is multiplication, right? So we can actually bring down each and every one of these little pieces. And then of the car's original value. And it turns out, what is the car's original value? This is what we're looking for, right? So we'll bring that down as our x. So if we want to get x alone, we have one final step to figure out what the car's original value was. Divide by 0.45 on both sides. And we get x is equal to 25,000, and we should go ahead and make sure we put the units back on. The original value of the car was $25,000. And in most word problems, it's even best if you can write out the answer in a sentence. The original value of the car was $25,000. Now, the one mistake students make is mixing up the two numbers, right? We know we have to multiply a number by that percent. So the only mistake we make is we have these two things backwards. But in a question like this, we should never make that mistake, because we have a used car. This is its current value. We want to know its original value. The original value had to have been higher. So if you gave me an answer here where you accidentally multiplied by 0.45 instead of dividing by 0.45, you would have told me that the original value was $5,062.50, which doesn't make any sense, right? There's no way the car was worth more before when it was brand new. So just keep that in mind. I do expect that you logically think about these questions and see, does my answer make sense? And I will choose nice, pretty things for you to look at like this, where if you use common sense, you should be able to get a lot out of it.